Dimensional analysis, or a fancy way to say unit conversions, is often used in chemistry and physics as an organized method of problem solving. This method is used to convert to units that you may not be able to measure in based on the tools that you have in your lab. In this video, we're going to talk about how you go about solving these problems and how you can show your work to even what may seem like the most simplest of problems. It will help you in the long run. The first thing we need to talk about is something called a conversion factor. A conversion factor is just that. It converts between two units. It gives you a quantity that is equal, so you can write it as a fraction with either number or value being the numerator or denominator. For example, we hopefully remember that 1 inch is equal to 2.54 centimeters. This is a conversion factor. Because it is equivalent, because there's this equal sign, we can write it as a fraction. So either 1 inch over 2.54 centimeters, because this equals 1, they're the same thing, or 2.54 centimeters over 1 inch. That is just another way to write conversion factors. There are 5 steps to solving every single dimensional analysis problem. Step number 1 is to write the number and unit you're given in the problem. Step number 2 is to find the conversion factor if it's not given to you. Step number 3 is to write both quantities as fractions. Step number 4 is to arrange the fractions so that units can cancel out, and we're going to talk about that in a second. And step number 5 is then to do your multiplication. So this problem says you have $7.25 in your pocket in quarters. How many quarters do you have? Well, step number 1 says to write the number and unit you are given in the problem. So 7.25, and I'm going to write dollars out instead of leaving it in the symbol. Step number 2 says to find your conversion factor. Well, in every $1, there are 4 quarters. Step number 3 says to write both quantities as a fraction. Well, 7.25 doesn't have a denominator, but we know that any number over 1 is equal to that number. So $7.25 over 1. And I'm going to rewrite this quantity as a fraction. So I'm going to put $1 over 4 quarters. Okay. Step number 4 now says to rearrange the fraction of the conversion factor, so this guy, so that units cancel. So what do I mean by that? Well, here we began with the unit of dollars. I want an answer in quarters, so I want to get out of the unit dollars. In order for me to do that, my only option is to flip this conversion factor so that dollars can cancel out and be in the denominator. So if I have $7.25 over 1, I want to multiply it by this conversion factor, but I'm going to flip it so that now $1 is in the denominator and 4 quarters is in the numerator. And this way that I've written this, these two things are equivalent. I've just flipped it so that dollars can now cancel out. Step number 5 then is to just multiply. So 7.25 times 4 divided by 1 times 1. gives me an answer of, let me just draw up here, 29 over 1, which is equal to 29, and our units are quarters, because that did not cancel out here. Let's do another example. This says a rattlesnake is 2.44 meters long. How long is the snake in centimeters? So step number 1 says to write the number and unit you're given. So 2.44 meters. Step number 2 says to find the conversion factor. So I know that every 1 meter is equal to 100 centimeters. If you're not familiar with that conversion factor, that one will probably be used a lot in the science lab because we measure in centimeters. Step number 3 says to write both quantities as a fraction, so 2.44 meters over 1 and 1 meter over 100 centimeters. Step number 4 says to flip your conversion factor so that meters cancels. So I need meters to be in the denominator, so 2.44 meters over 1 times 100 centimeters, and again all I did was flip my conversion factor. And step number 5 then is to multiply, so we are left with 2.44 times 100 over 1 times 1, which is equal to 244, and meters cancel, so we're left with centimeters. This next problem might seem pretty simple to you, but I want you to show your work so that you can understand that this is what you do on a daily basis when you're faced with these types of problems. So this problem says, suppose there are 12 slices of pizza in one pizza. How many slices are in 7 pizzas? Well, the first thing we need to do is determine the number and unit we're given. Well, we're given 2 numbers. We're given 7 pizzas and 12 slices of pizza in one pizza. So which one do we start with? Well, the rule, which we're going to cover more later, is to start with the number that only has 1 unit accompanying it. So as you can see, 12 slices and 1 pizza, that's 2 numbers. That's pretty complicated compared to just 7 pizzas. So we're going to begin with 7 pizzas. Number 2 says to write your conversion factor. Well, this other information that we were given is now our conversion factor. It says that there are 12 slices in one pizza. Okay, so step number 3 says to write them both as fractions. So 7 pizzas over 1 and 12 slices over 1 pizza. Step number 4 says to flip the conversion factor so that the unit you began with cancels. Well, right now I don't have to rewrite this because pizza is already going to cancel out. So step number 5 is to just multiply. So 7 times 12 over 1 times 1 is equal to 84 over 1, or 84, and pizzas cancel, so we're left with a unit of slices. You probably would have known to just multiply 7 times 12 to get the answer to this question, but you're really doing dimensional analysis. In your head, you're doing all 5 of these steps, whether you think so or not. So it's important to show your work because it's going to get more complicated than this, and you won't just be able to do one simple multiplication in your head. So what I'm talking about is that most problems are not simple one-step solutions. So sometimes you'll have to perform multiple conversions. So everything that I've been giving you so far is 1 foot equals 12 inches, 1 inch equals 12 centimeters. Everything that we've done so far has been a one-step conversion. We have used one conversion factor and done multiplication once. It's not always that case. In fact, it's almost never just one step. The steps for solving problems with multiple conversion factors don't really change from just one conversion factor. So step number 1 is still to write number and unit you're given. Step number 2 now is to find all conversion factors. Step number 3 is still to write all quantities, so every conversion factor and the number and unit given, as fractions. Then step number 4 is to arrange and flip conversion factor fractions so all units that need to cancel out can cancel out, which we'll demonstrate in the next couple examples. And then number 5 is then to multiply again. So in this example, which says convert 5,234 millimeters to inches, we recognize that there's not one direct conversion factor to go straight from millimeters to inches. You are going to be usually given conversion factors, but it is good to know some off the top of your head so that you can maximize the amount of time or minimize the amount of time you spend doing these problems. Well, I know that there are 10 millimeters in every centimeter. I also know that there are 2.54 centimeters in every inch. So step number 1 says to write the number and unit I'm given, so 5234 millimeters. Then I'm going to write my conversion factors in step 2. Step number 3 says to write everything as fractions. Step number 4 says to rearrange the conversion factors so that units that need to cancel out can cancel out. So if I start with 5234 millimeters over 1, I need to multiply by this conversion factor so that millimeters is on the bottom. So I need to flip this. So I'm going to have 1 centimeter over 10 millimeters. But it doesn't stop there, because right now if we were to end this problem, we would end in the units of centimeters, but we want inches. So I have to multiply by this second conversion factor, which I have centimeters on top here now. So I need centimeters to be on the bottom of this next conversion factor to cancel, because I don't want my answer to be in centimeters, I want it in inches. So I need to flip that last conversion factor, so I'll have 1 inch over 2.54 centimeters. And then step number 5 says to multiply, so 5234 times 1 times 1 over 1 times 10 times 2.54, which equals 5234 over 25.4, which equals 206.1, and we're left with a unit of inches. So multiple conversion factors or multiple step problems don't change anything about how you do the problem, except that you don't just end after the first conversion factor. You might have to keep going to get to the unit that you need. But it's also the same idea that you keep flipping the fractions and canceling out your units until you're left with an answer in the unit that you want, or that the problem prompts you to give. It's like here it says inches. So inches should be the one thing that's not canceled out and when we show our work. And as I have shown here, it is not canceled out. I'm going to work through this next problem here that says calculate the number of seconds in 2 weeks. Well, I was given 2 weeks. So that's step 1. Step 2 says to figure out conversion factors. Well, in every week, 1 week equals 7 days. 1 day equals 24 hours. 1 hour equals 60 minutes. And 1 minute equals 60 seconds. So step number 3 says to write everything as fractions. 2 weeks over 1. 1 week. 7 days, 1 day, 24 hours, 1 hour, 60 minutes, 1 minute, 60 seconds. So go ahead and make sure you have this copied down if you're following along, because I'm about to clear the screen, so I'll give you a moment to do that. So step number 4 says to rewrite everything so that you get stuff to cancel. So I'm going to make my pencil smaller here. In 2 weeks, and every 1 week, there are 7 days. Every 1 day, there are 24 hours. And every 1 hour, there are 60 minutes. And in every minute, there are 60 seconds. So now go through and make sure your units cancel out. And you're only left with seconds because that's what the problem asked you to solve for. So if you're confused about what I've written, this is the same thing as saying 2 weeks over 7 over 1 times 24 over 1 times 60 over 1 times 60 over 1. This is the same thing. I just like to simplify it with boxes. So we'll be left with 2 times 7 times 24 times 60 times 60 all over 1 times 1 times 1 times 1, which is going to equal 1,209,600 over 1, which is just 1,209,600 in units of seconds. You probably won't see a problem with any more steps that you have to do. Like this will probably be the most number of steps that you would have to do in a problem.